are going to get introduced to this new word called multiplicity. And look what happens when we have an x-intercept that happens more than once. And they start us off with something we know, which is a parabola. You have x squared minus 2x plus 1. If you factored this, do you see that you would get x minus 1 twice? And if you solve for your x-intercepts, you would get x equals 1 twice. And when we graph that, x equals 1 is the x-intercept. We would know that our y-intercept, when you plug in 0, is positive 1. And we know that our end behavior of a parabola looks like this. And so we already know this graph of x squared. And we're going to say, and now define, when an x-intercept happens more than once, it has a multiplicity. And that multiplicity does something to the graph at that x-intercept. So far, all of our x-intercepts, when we've drawn them, our graph has gone straight through our x-intercepts. But notice in the parabola, in this particular case, at that x-intercept, I'm going to call it, this is not a technical mathematical form, just going to describe what I see. You see it sort of bounces off the x-intercept. Doesn't go through the x-axis anymore, it bounces. So we're going to find out when we have an even multiplicity. Maybe we'll write that off to the side. The graph bounces at the x-axis or at that x-intercept. If you factored x cubed minus 3x squared plus 3x minus 1, it would factor to x minus 1 cubed. And x minus 1 cubed, you know what that looks like as well from the beginning of the year. Because the x cubed graph was a graph that you knew. This minus 1 would move it which direction? 1 to the right, left, up, or down? To the right. Which kind of makes sense because your x-intercept would be 1. And it moves it 1 to the right. And what did our x graph look like? Our x graph looked like this. Technically, when we drew our x graph, our x cubed graph, technically a lot of times we actually didn't graph it perfectly. At this point, I'm going to take away my blue graph. It actually quite flattens out, so it should have had even more of a flattening out in our curve than we usually drew. We usually just drew it quick, and it probably didn't flatten out enough. Okay, so we'll also add a note for our x cubed graph that when we have odd multiplicity, okay, again, here are our descriptive words. If an intercept has an odd multiplicity, then the graph flattens out and bends at that point. And so you are going to be able to graph example 3 really quickly using this idea. Okay? These are already factored. And because they're already factored, some of the preliminary stuff that we did before is a little bit harder. So one of the preliminary things we always did was the end behavior. But because it's factored, you have to multiply it out, but not completely. If you multiply this out, you just have to tell me what's the very first one going to be. You multiplied out x plus 1, x plus 1, x plus 1, x plus 1 times x minus 2. And you took all the first ones that were there. You see that you would have x times x times x times x times x. It would look like this. Because we have x 4 times there and another x there, all 5 of those first x's would all get multiplied together. You would get an x to the 5, which means your leading coefficient is positive, it's odd, has the highest degree. There's our end behaviors. The other thing that is a little bit more difficult because it's factored is the y-intercept. You actually have to do a little bit of mental math. If you plug in 0 for x, do you see that you would get 1 to the 4 and then plugging in 0 times negative 2? And that's going to equal negative 2, so our y-intercept is 0, negative 2. But the extra time that it takes to find our end behavior and our y-intercept is definitely saved, because if I gave you an x to the 5 and asked you to factor completely, it would take you some time. All that synthetic division you'd have to do over and over and over again to factor it completely. So we're actually quite happy that it's already pre-factored, because since it's already pre-factored, maybe I'll rewrite it down here below. Right? If we want to find our x-intercepts, we plug in 0 for y, and it's already factored. And we would say x equals negative 1, and I'm going to put in brackets here multiplicity of 4. And x equals 2, and in brackets, that's a multiplicity of 1. Anytime you have a multiplicity of 1, the only one odd is bending and flattening out, only when it's bigger than 1. When it's 1, just like before, your graph is just going to go straight through that x-intercept. So now when we go to graph, I have the following information. I have my y-intercept at negative 2. I have an x-intercept at positive 2 and an x-intercept at negative 1. I know my end behavior was an x to the 5 graph. It has to start down here. And end up here. This multiplicity of 4 tells me it's going to bounce. Smooth around, bounce through it, go through my y-intercept. This one has a multiplicity of 1. It needs to go straight through. And we have our graph with a bounce and a straight through because of multiplicities. Do you know why I would lose a half a mark on this graph? I didn't label, right? If you don't label, your scale means nothing. So it's very important that you label. I'm going to label my intercepts, then I'm fine. But without labels, we would lose some marks. So we would do, I'm going to leave part B. You can try it on your own. But in part B, okay, you would have to multiply that out to find your end behavior. A little bit trickier because you have an extra negative out in front. You would have a negative x to the 4 graph. You would have to find your y-intercept by plugging in 0 and multiplying everything out. But our x-intercepts are -1, and that one's going to bend because it is a multiplicity of 3. And we have an x-intercept of 3. That'll go straight through. I mean, we can almost graph it super quick here. -1, 3, and behavior is going to go down. Y-intercept, if I plug in 0, I'm going to get 1 times -3 times 3 times negative is going to be 3. This one's going to bend and flatten out, so sometimes on the flattened out ones I draw a little tiny straight line that makes sure that I have it bend. So I'm going to start end behavior. I'm going to start down here, hit the flat line, bend it, go through this one, and straight through. There's my graph. And I'm going to have marks for not labeling, put the bell in. Okay, you can circle questions 9, 10, 11, and 12.